Hello, in this video we're going to talk a little bit in more detail about how to use the Adaptive Map Viewer and how to kind of take advantage of all the features and the visual cues that we have. So we're going to go ahead and start the tool up. It opens up into the overview. So again, the main idea here is we've got a network of connected ideas. We've got a map of all the information we're going to learn in this subject. So a few things that we'll do before we go into what all this means. I'm going to show you some basic things you're going to need to navigate the map. So I'm going to tell you how to pan, zoom, search, and some of the other options. To pan, to move around like this, there's a few different options. So if you click and hold anywhere in the background, you can kind of grab and hold and move around that way. Also, if you click on any one of these nodes, it'll center the view on there. So that's how you pan around in the information. To zoom in and out, you can use the scroll wheel if you have one. So the scroll wheel lets you zoom in and out. If you don't have a scroll wheel, you've got the plus and minus buttons over here, lets you do the same thing. Searching, we've got a search bar up here. So if we go ahead and search for, say, forces, it'll give me all pages, all ideas that have to do with forces. There's a lot on forces here, but if we go and select any one of these in the box that pops up, it'll zoom us into that specific topic. So let's go ahead and zoom back out to the overview. And if we go to the options, you've got a few different things here. Enable node dragging simply lets you move the nodes around yourself if you want to reorganize them. You can increase or decrease the font size, and reset the node positions will let you reset the nodes if you have moved them around with the enable node dragging. So I'm going to go ahead and hit OK. And the last thing is this back button will let you follow the course you went back through. So I was clicking on work and energy and forces before that, and so on. So it'll let you go back through the nodes you've looked at. And next we've got, we're going to look at the different levels. So here, this is the overview. This is the display of all the information taught in engineering statics organized into a couple clusters. So each one of these nodes represents a number of ideas, kind of like a chapter in a textbook. There's a bunch of ideas that are presented in any one chapter. And the links represent relationships between ideas in those chapters. The thicker the link, the more relationships there are between these two. So there's a lot of relationships you can see between static equilibrium and multi-component assemblies. There's a relatively light relationship between static equilibrium and vector and matrix math. So more related is thicker arrows here. If we go ahead, we'll go to the next view. So let's click on multi-component assemblies. We zoom in, and this expands out into the cluster view. So now here in the cluster view, there's a few things we can talk about. So you'll notice the background color has changed to let us know we are in that chapter or that cluster. And we see that most of the nodes match that color. So this is all the information in the multi-component assemblies cluster. This one up here is a different color. This is a node in a different cluster. So if I go click on this, it'll change clusters for me. So now I've entered in a different cluster in the overall map, and I've changed my place in the overview. But let's go back to multi-component assemblies. So here in multi-component assemblies, all of the links are single wide. There's only direct relationships at this level because any one idea can only be connected or not connected to any other idea. We've got labels for these links as well. So here we've got the information flowing from the top down with these directed links. So you want to read Newton's third law first, and then you can read about multi-component assemblies and follow the links downward to learn this information. And each one of these links represents a relationship. So this says this is an app link up here, and that means that the source concept is applied in the destination concept. So we use Newton's third law a lot in analyzing multi-component assemblies. And so on. The destination is a subset of the source, that's the sub node, and that indicates that a machine is a type of multi-component assemblies. All this information is organized into kind of this map that you can plot your course through to learn the information. So if I want to learn about this idea and I know nothing else, I'm probably going to need to learn about multi-component assemblies, two-force members. Then I can learn about trusses. Then I can learn about static determinacy in trusses. So this gives me a way to get to that idea I want to learn about. And the gradient here, if I focus on any one node, you'll notice this center node is the most colored, and as I get further away, I get more and more white, I get less and less of the color. This indicates how closely the ideas are to the one I'm currently selected with. So with that, you kind of get the idea of the cluster view, and if I double click on any of these, it'll open up the page view. So this is the detailed information that I would have. So here I've opened up the page on static determinacy and trusses. This looks kind of like a traditional textbook. You've got some text explaining what this is, some images helping to explain that, and in some of these, let's go to the method of sections. If I open that page up, you've also got worked examples here at the bottom. So this is the information you would find traditionally in a textbook, and you just navigate through the information with this tool. That gives you kind of an overview of how to use this tool, and I hope with that you can go and make full use of the tool. The tool is at www.adaptivemap.me.vtd.edu, and I hope you find the tool helpful, and thank you for your time.